Hello and welcome to the Rustacean Station. I'm your host, Alan Wyma, and today I have a really great guest. I always say very special, so maybe change it up a little bit. A great guest today. It is Sean McArthur. I believe is how you say your name. Okay, I'm happy. You should nod in your head. So Sean is, I don't even know if you're I know you're, of course, you're the lead, but I don't know if you actually created this project, which is the Hyper project, which has garnered quite a bit of attention in recent months, right? You're working with curl. You're kind of a piece of, I would say, nearly every web framework in the Rust community. Definitely, I would say. And I don't know many people who are not using Hyper. But yeah, I wanted to bring you on to talk more about Hyper and kind of, what it is and how it all works, and also talk about how your work with writing some C APIs with this too. But anyways, why don't you just give a quick intro of yourself, Sean?
Yeah. You said it right, Sean McArthur. I go by the handle Sean Monstar online. I've been working on Hyper for a while. I'm the original author, and I've been working on it for 7 or so years. And it's really awesome to see it take off. Yeah.
So what actually got Hyper rolling to begin with? Like, why did people decide to start working on Hyper?
Well, I was originally a back-end developer doing JavaScript at Mozilla, working on servers, and I kind of hated it. It was fine at first, but then eventually, after you get tens of thousands of lines of JavaScript code deployed to production, it's horrible to refactor. Even though you have tons of tests, you ship something and inevitably pagers go off because you managed to miss it somewhere. So I started digging into other languages, and it just so happened that Mozilla was also working on Rust at the same time. So I took a look and was curious. There are a whole bunch more pointer types and sigils back then. It's gotten cleaner since. But I was really intrigued by the type system being really expressive, but then at the same time being kind of free and everything being fast, whereas JavaScript was not. But so of course the first thing I wanted to do when I got into Rust was to make websites. I was a web developer, and there wasn't really much of a HTTP stack at all. So that was where I ended up. So I first did like a small little project. I don't remember what. I think L20N parser or something like that. But then quickly, like, well, there's no HTTP, so I guess that's what I'll work on. And it kind of grew from there. Hyper 01, the first release, was in January 2015, 7 years ago.
2015 doesn't seem so far away, but yeah, it is quite some time ago.
Yeah. The pandemic has taken 2 years, but now we've got 149 releases, 283 contributors. So people just showed up and started wanting it to do more, and eventually we added in async support, and that went through a couple of different revisions, and there was Future 01, and that was a fun ride. Made things async, made things cheap, kind of like the iterator trait, but had this fun world that we had from JavaScript that people call back hell. And then we got async and await a couple years ago, and now things are amazing and wonderful.
But I'm kind of curious. So when you initially started this, like, what was actually backing or underneath the hood? I mean, was there actually Tokio back then? I'm not too sure when that project started.
When starting Hyper?
Yeah, I think Hyper, yeah. Because I don't think there was necessarily Tokio, but there was the Mio or Mayo. No, there wasn't?
No, Tokio wasn't out yet. Mio might have been started, maybe. When I first started working on Hyper, the Rust standard library had 2 runtime modes. I think it was libnative and libgreen. And the default was libgreen. You would have these kind of coroutine like things automatically, kind of like Go. And so there wasn't really too much of a need for async. But then Rust wanted to be more portable and have less of an opinion on things, and so they got rid of that. And then Hyperstar only had blocking I/O, which was okay, but eventually when you want to start scaling servers a whole lot, then you start reaching for async I/O. And there was Mio, and there were some experiments around things, Futures I/O. I think the Rotor was something, but then Tokio kind of became the most prominent answer for async I/O, and Hyper piggybacked on that.
Okay, so what do you think the experience between then and now with async await and the system used before? I mean, you used the green threading system before, right?
Yeah, back then it was kind of like Red and Go, where you didn't even think about it. It was just async under the hood. Now, as a goal of being more transparent and letting you know that there are yield points here, you write these async keywords and await, and it kind of implies that code could yield here, this cooperative yielding, and it's not worse. Maybe it's better because it's more transparent, but it's a whole lot better than when it was just callbacks. So everyone who didn't try it out a few years ago and is trying it now is in a better place.
Yeah, I find the syntax to be a little bit strange. I mostly still use Elixir, and this one you can spin up a task and it starts going, but like you need to do .await, and I find that a little bit strange. And I feel strange. Like, how can I like just spin off a task and just let things run? But then there's Tokio, and they have something you can spin off tasks with, because it seems pretty okay. I just gotta get used to it. Otherwise, I just feel like if you use the vanilla style, it's hard for me to understand how can I have a bunch of stuff running at the same time.
With something like Tokio, you can just use Tokio spawn and it's like a lightweight thread. It's a task, but yeah, you have to sprinkle await everywhere. It's a way of telling the compiler then uses that to compile a state machine to know when the code might be able to yield and do, like wait on I/O or some other thing, a timer, whatever it's waiting on, and start executing another task.
Well, the nice part about everything is that it is still synchronous in the fact that you can just easily read top to bottom. You can understand what's going on. Some other systems, they maybe not so clear about where the starting point is.
Mm-hmm.
But okay. So when you started writing Hyper, because what I understand about Hyper is maybe you can explain it a little bit better. It's actually like a client and a server-side component.
That's right. It has both. Yeah, you can use it as a client or a server. So when I was working on it, it used to have kind of the server and the client separated from each other. But the more and more that I worked on it and recognized that a lot of the stuff is the same, a lot of the core HTTP stuff it can be reused. You just need a little bit of customization based on the role, whether it's a client or server. That stuff got refactored into a central thing. And then Hyper has these cargo features. So cargo has this ability for you to, when you depend on a crate, to say, enable this feature. And inside that crate, there's a bunch of conditional attributes that will either compile the code or not. And so Hyper uses that to allow you to say, I only need a server. I don't need any of the extra client code, the connection pooling and anything like that. Or the other way around, you might be like, I only need a client. I don't need a server. And so you can cut out some code there. But a lot of the code is reused, like a reusable core that fits into both sides.
Okay, so if I want to use the client side or the backend side, that's just a feature flag away, it sounds like.
Exactly. Yeah.
Okay.
You just put it in your cargo toml as Hyper features equals client, and then it won't compile the server stuff.
Okay, I didn't even know that, but that makes more sense, because I always find it strange, because to me they're two different things. So when you say it's like Hyper, it's like, well, do you mean the client side or the backend side? So that's pretty cool. Okay, so when you started to work on it to when things started really taking off, like Was it a single feature that really made it interesting, or was it, like you said, was it just that nobody else was making something in the Rust community, and then they just kind of gravitated to Hyper?
Yeah, it was more kind of like what you said. There was one other effort by Chris Morgan. He was working. He wrote out some thoughts on, I think it was TPRS, but there wasn't really code, and so I started working on Hyper to scratch my own itch, and a few others contributed, and then made some web frameworks on top of that, and I started working on a like Python. There's this library in Python, Reqwest, which is like a batteries included client library. So I started working on a similar thing like that, figuring like, okay, Hyper is not going to be that opinionated. You can twist it however you want, but there's a lot of opinions that people could have, and Reqwest is going to have those opinions, and you can use it and make your life easier. But if you need to swap out some batteries, well, that's Hyper is the entry point for that.
Yeah, I've used Requests for one thing a long time ago. It was kind of nice. I found it a little bit strange at that time, like you could say you want synchronous or you could say you want asynchronous, which I thought was a little bit strange. But I guess, well, what's the point of giving people an option nowadays? I feel like you should just give them asynchronous with the future await.
Yes. So originally, the blocking one was the default, because that's when Hyper was blocking. And then we added in async support, and so then async support was this like optional thing that you could opt into. But then eventually, as async and await matured, we made the async API the kind of default one. But we didn't get rid of the sync one because you realize that there's actually quite a lot of applications that don't care about async at all. Maybe you're making some script that does a little bit of work, fetches a website or two, calls an API, and then continues to do a bit more work locally. You don't actually care about it being async. You just want a couple of API calls. And so that's what the blocking feature is in Reqwest now, is realizing some people just want it to be easy.
I'm just trying to think if there's even a benefit to have asynchronous. Is it just that you just want to go top to bottom and just you don't really care about, like you said, you don't really care about the having asynchronous kind of runtime in your app?
Yeah, and having async and like you said, using await everywhere it's kind of confusing. So if people don't need to learn it, and they don't need to handle tens of thousands of connections, they just need to send a couple of requests, then that's what the easier thing is for. And it performance wise, it doesn't cost that much more. So if it's going to be, just the cost is minuscule compared to how much easier it is for someone who doesn't care.
Okay, that's interesting. Like, I'm just kind of curious if, besides that, is there really any other good reason to go for the blocking route?
That is the main reason. If you want to try and maximize performance of your hardware, then I'd reach for the async one.
Is there actually like a difference if I'm just say, let's just say I'm running like a simple like 10-line thing, and I do like a request and grab some data, like, is there any benefit to use async over just the blocking?
No, not really. That's what the blocking one is pretty much for. You're making a 10-line script, then yeah, just blocking get and forget about it.
Okay, that makes sense. Do you actually advise that too, or you're just saying whatever you want to use is fine?
I mean, if it's not like using the async one is going to be horrible. It's still going to be good. It's just, if you don't want to have to figure out how to use async and await, you don't have to.
Yeah, when I did my project, I think I also had to work with some files too. So in the end, I just felt like, yeah, I better just go originally I tried doing the blocking route, and then I just said, well, I have to pull in, I don't know, for whatever reason, I decided to go to async await part with files. And so I said, all right, well, since I already have to pull this one in, I might as well try out the async side for this one. And so it worked out for me.
Sure.
What about the relationship between Tokio and Hyper, right? So like when did you first start to say, okay, this is getting interesting, maybe I should add this to Hyper?
I don't actually know when. I'm going to guess that was 4-ish years ago. But Years are hard. Kind of as Hyper was trying to get into async Rust, was working a bit on. I tried making my own thing over Mio, and then noticed another project which was doing something similar, and I figured, well, why should I make another? And then Carl approached me. Carl Lersch, she's creator of Tokio, and pointed out that was something that he was working on, and it had a much nicer model, because the model was before the. I think I have a blog post somewhere about the async API that Hyper was going to have, where you had to kind of register interests, like I want to read or I want to write, and then you would eventually get the data, or you'd eventually be able to write the data. And Tokio took the approach of just try the operation, just try to read, and if it's not available, then it's going to automatically register the interest. And that model just felt very natural, and so I latched onto that and built Hyper using that model instead. It worked out great, I think.
No, we can back up even a little bit more, right? The Mio thing. When did that come onto your radar, and you're just like, you know what? I know this is just not going to work out, and we're going to have to scale, so we should go this direction. Or what was the thought about that one?
Yeah, I mean, it would have been not too much time before that, maybe 6 months before that, when I was thinking about, okay, I need to get into async IO. This has been a fun experiment, but let's get real and make an actual HTTP library that can scale. And Mio was the thing to look at. Yeah. I don't remember beyond that.
Okay. Yeah, but there's also more than one async runtime. So Hyper only can run on this one, right? On the Tokio.
That's somewhat true, but not really true. So I don't know if that's true.
Okay,
true.
Please explain.
Yeah.
Please elaborate. I need a footnote.
Sure. Hyper has integrated support for Tokio. So if you enable the runtime feature, it will just use Tokio, assuming that Tokio is there, using Tokio spawn, Tokio's IO traits, Tokio's timer, etc. However, it can be built without the runtime support, and then it can work with any of the other runtimes that exist that I know of. For instance, Google's Fuchsia project, they don't run Tokio. They have their own IO stack, networking stack, but they provide so Hyper is generic over a couple of traits, over the IO traits. You just have to provide an implementation of that. So Fuchsia does that, for instance. This is also how curl is able to work with Hyper. It provides its own IO, and then Hyper just does the HTTP over that. So it can work with any of the runtimes. You just need to provide the IO implementation. And for ease, we provide the Tokio one as a built-in feature, but you can disable that.
So actually, that's a pretty good point, right? So that must be a pretty big deal to you that you're like, wow, I'm actually being used in Fuchsia, and you're finally out there, right? As a couple of months ago, I forgot when Fuchsia kind of came out for the Nest. I mean,
oh, that's right.
Did Google actually reach out to you to talk about, hey, we really want to use this, or you just kind of found out one day when somebody kind of dug through the code base?
Yeah, more the latter. No, there wasn't really any official inquiry. It was just, Fuchsia's been open source for a while, and you could look through the crates and find references to different ones. And then sometimes Google engineers would show up in a bug and, hey, we found this. Oh, how'd you find it? Well, over here in this crate doing, I don't remember what. And you'd learn, oh, okay, cool. It's being used in Fuchsia. I don't know what that means, but that's cool.
Yeah, I think Fuchsia is quite interesting, right? Because I would say it's the only kind of main, quote unquote mainstream OS out there. I mean, there's a lot of OSs written in Rust, but not many that are really somewhat mainstream, and that's because Google has their reach, right? So I don't know what they're going to plan to do with Fuchsia. It's like you got Chrome OS, you got Fuchsia now, you got Android. I don't know what the heck they're doing. And I don't know. It's just interesting to see what's going on. But I guess each OS has its own reason, right?
Yeah. I don't have any insight into what they're doing with that either. But I know that they did a big push into async Rust. A few of the developers helped figure out async and await for a while, and Google was a big user of that work. Using it in nightly at first and helping to make sure the design worked out. So that was very helpful.
Speaking of that, I'm just kind of curious. Do you know of anything else that's actually using Hyper directly? I know, of course, we're going to talk a little bit more about curl later on, but that's kind of another story. But is there anything else that's using Hyper underneath that maybe we would know?
Yeah, it's used in a lot of really big places. I work at AWS and it's used here in a few places. It's used in Microsoft and Facebook uses it. We already mentioned Google. Cloudflare, Fastly, Dropbox, Discord had a really nice big blog post about how Rust helped them out. You mentioned curl, quite a few different places. It's pretty cool. Kind of scary too.
You feel a little bit in a dream. It's like, wow, my thing I kind of wrote because there's nothing out there now is powering quite a few interesting projects. You feel a little bit overwhelmed or no? Or do you feel like when you write your code now, I'm just curious if you ever feel like nervous, like, ooh, I got to be careful when I write this one. This may hurt somebody.
Yeah, in a way. At the same time, I've kind of, I hope I've always worried that if I wrote bugs that I'd hurt someone. But it can get daunting if you think about, oh, this bug could take down a lot more than someone's pet project. That can be scary. So you just don't try to think about it, or think about it in a healthy way, really.
Yeah. Sorry if I brought the pressure on. I feel like your mood changed. Like, oh yeah, you just reminded me of something.
Forget this. I'm out of here.
Yeah.
No, it's fine.
What I think the nice part about, like, I understand this side of, like, I have to be careful. This is not like not like it used to be, but at the same time, I think you have a lot more eyes, right? So you can probably get some protection of people catching things that maybe are not quite there. You probably just put up a PR and see what people say. Maybe we could talk more about the governance of the Hyper project, right? Because now that it's much more popular, it's being used lots of places. You must have some kind of governance going on, right? So, like, if I want to contribute to Hyper, even if you want to contribute to Hyper, I'm sure you're also part of the process. I don't think you're the kind of person that just commits to master and then releases. Maybe there's an emergency or something, I don't know. But what's like the governance of adding features to Hyper?
Yeah. So first, something you mentioned, that it's very useful to have all these other people using it and engineers. That is wonderful. It has helped find all these edge cases. On the one hand, you could think like, oh, that means that there were so many bugs, but really, all software has tons of bugs, and by using it, you're able to help clean them out. So that has been super useful to have people deploy it in these weird environments that are touching crawling websites or proxying websites and doing weird things with HTTP. It's helped make the library a lot more stable. Around governance, it's kind of a benevolent dictator for life format at the moment, where I guess I have final say on the things, but I much prefer seeking consensus from people. Well, seeking opinions from people that I think would know better or would have some good input. Trying to, follow pull requests. I love making kind of RFCs sort of issues where working out, like what's the impact to the user and what's the change of the API and what's the pros and cons and try and pinging a few people from these different companies to weigh in. And then we try to come to the best option that will work for everyone. Of course, not everyone agrees, but ideally they're in the minority and things work out.
I mean, is there anything kind of controversial that you think that you kind of pushed through that people really didn't like? and anything like that? It doesn't sound like it.
No, not necessarily. Like super controversial. I mean, there might be people who might say, "Oh, it shouldn't include Tokio support by default. It should, or something like that." But that was more measured well. But there's so many more people that are using Tokio that it's actually, in my opinion, a net positive that it's easier to use. Like something like that. But nothing hugely controversial. No.
Yeah, I also find this really really interesting that like so yeah, I don't really understand like about the whole async runtime and how it seems like when you create some type of async lib, you have to actually latch on to something, power it. You can't like you'd figure that it should be abstracted, right? And you can choose whatever runtime makes the most sense to you, but it seems like it's not like that. Is there like a reason why? Because I think you were kind of also saying this before, yeah. Yeah, you have to use Tokio, but you can use other things, but really it's also kind of a misleading thing too, because if you can use others, because if you go to Tokio.rs, you're listed there, right? So like what's kind of the story about this style of yeah, you have to kind of choose something that you work with.
Yeah. I mean, we originally chose Tokio because it was pretty much the only option at first, and it was quite nice at the same time. And then some other options started to appear, and in order to support that, Hyper had grew the ability to, well, you can just disable the runtime features and bring your own, and that fit the needs of Fuchsia and anyone else who wanted to use a different kind of runtime. And but the point about needing to kind of pick a runtime, it's kind of complicated, but it's also not that complicated. You kind of need a way to be generic over a runtime, like being able to say these are the APIs I need, like IO traits, timer traits, task spawning, and where do you put those traits? If you put them in, say, Hyper, then all the runtimes need to use Hyper. No, that's not possible. So then you need to have like this glue crate that kind of marries the two, and that's kind of annoying too. So then there's this effort to try and get these core traits into a core library like Futures, maybe eventually into the standard library. But that saw some resistance, as there was a difference in opinion of what the traits should look like. And then as well, now they're currently paused as we're the group working on the async working group is wondering, well, do we really need to have all of these polling functions? Because that's another thing, is the way these things work is you actually poll futures, but most people who are using async and await don't need to know that they're polling them. They just want to await them. And so as soon as you start getting into like you wanting to make a timer or async read or write or something like that, all of a sudden you're writing these pull functions and you can no longer await things, and it's like a completely different world. So it's currently on pause to get into the standard library, because they're wondering, well, can we just make these functions on a trait? Can we make them async functions? And then it's really easy to write and everything is wonderful. So that's where the current speed bump is, I guess.
Yeah, I just wish there was a way that you could just say, this is the standard kind of interface, plug in whatever runtime you want, and then that would be the end. I'm just kind of surprised that it's not more like that, even though there's like a standard, like you said, there's a standard trait, right? I just thought that would be enough, but apparently it's not.
Yeah, it's many people want that. It's not missing because no one wants it. It's missing because of other problems. But at the same time, many people are able to deploy things to production, even though this doesn't exist. Many languages have a similar problem and just live with it. There's IO libraries in a bunch of different languages, and you just kind of choose, okay, these are the pros and cons of one over the other, and well, this is what I need for my application, and let's see what ecosystem there is around it. That's currently how it is in Rust, and we'll see how it is in a couple years.
Yeah, I'm happy that things are moving forward. I feel like things are getting better and better every release, so that's the good thing, right? You feel the same as a library maintainer?
Yes, that's the hope. Um, Hopefully things don't get worse. Um, yeah, I think things are getting better. It'll be good if we can eventually no longer have to write pull functions, and not have to teach people what pin is in context, and that'd be wonderful.
Oh yeah, pin. I have to read more about that, but I remember that's kind of a little bit of a tricky subject. And judging by your smile, it's also interesting. It sounds like.
Uh, yeah, interesting. Um, in that I'm not sure that anyone fully knows how it all works. Um, there's a whole documentation page and some blog posts trying to explain how to think about pin. I don't think I can do it justice in a couple minutes here, but the idea is, since there's no garbage collector, you've pinned the thing in place in memory, and it doesn't move, so it's okay if it has references into itself. Um, it wouldn't be okay otherwise, because if you were to say take a reference over an await point where it could yield, and then you were to move the future in memory, then you'd have invalidated references. Since we don't have move constructors, that makes that impossible. So pin gets around that by it kind of a social construct, um, in that you've basically agreed if something is pinned, then I won't move things. Is what it's kind of come down to. I mean, then again, most of the type system is more of a social construct that we've all agreed to, but still.
You're starting to get a little bit philosophical about this stuff.
Yeah. Like, real, what is send? Well, it's really we've agreed not to send across a thread. Never mind. Going down a rabbit hole.
Exactly. But yeah, talking more about Hyper, right? So I am kind of curious. So Hyper is kind of part of the umbrella of Tokio then. I mean, obviously it wasn't in the beginning, like what was the discussions of saying that this should now be included kind of part of Tokio?
Um, it's kind of in a blurry spot, where it tries to still be its own thing, but at the same time it works really well with Tokio, and so it's in the documentation. It's recommended to use if you want to use HTTP with Tokio, but it's also its own project with its own goals and governance and whatnot.
So how come it's listed on the website though? That's the strange part. I haven't looked in to see where exactly Hyper is in GitHub, but I'm guessing it's in its, like you said, it's its own project. Yeah. So this was must be you. Wait, why is it there's more than
Yeah.
one Hyper? Oh no, it's because it's Hyper Terminal. Yeah,
Oh, right.
Hyperium,
Hyperium. Yeah.
Hyperium Hyper. Yeah, but yeah, it's just confusing and misleading. I think to put it on the Tokyo website, unless it's actually part of the umbrella and really into the project.
I'm not sure I know the full answer on that one. I mean, the the all the projects that you see on the Tokyo website are all things that the group of us, all kind of work on together. Kind of similar to, like, if I scroll down and I see tracing or bytes. In some ways they're part of Tokyo, but at the same time they're kind of able to be used without it and kind of live on their own. And like tracing is used by the compiler, for instance. Bytes can be used by plenty of other things besides just Tokyo apps. Same thing with Hyper. It works with Tokyo, and if you want to use HTTP with Tokyo, you should probably be using Hyper. But you can use it on its own, as we mentioned.
Yeah, I think that makes sense now. So it's like basically the glue that sticks all these projects together is that it's the same group of guys mostly working on these projects, and you guys are kind of maybe the Tokyo crew
Yeah,
who kind of work on these.
yeah, pretty much.
Okay, that tends to make a little bit more sense. Yeah, and I do also like that you guys actually try to make sure that you're not too dependent upon Tokyo, which is also good, right? Because yeah, not everybody can use Tokyo runtime for whatever reason.
Yeah.
So then Reqwest, right? So like I said, I use Reqwest in the back. So that one
Mm-hmm.
is also done by you. Yeah, I guess it's to scratch the itch, and I guess the name Reqwest is a pun to the request library, right? For Python, like you mentioned.
Yeah, it's a request with a W instead of a U, um, mostly
They
because
change it just enough so you don't get sued, right?
I have no idea. Um, more so the request with spelled correctly and even request with an S were both already taken. It turns out I considered reaching out to the people that had those and asking if they wouldn't mind transferring it, but as I worked on it with a W, it turns out that it kind of made it easier to Google, to look up things. If you were to just Google Rust request without the W, yeah, you'd have a bunch of results. So in some ways that's useful. Um, Occasionally people complain, why it's got to be spelled wrong? But I don't see how that actually affects whether or not you can ship code in production. So just opinions.
I'm so used to people always putting their own little weird spelling on things that I don't really think too much about it. In fact, it makes it easier because now you can say, request equals, right? You can use that as a variable.
Yeah,
So
sure.
so this is a feature, not a bug to me.
We'll go with it.
Okay. Now I think I want to start to roll a little bit more into like curl, right? Because we had, I think our very first guest actually, this is quite exciting, is Daniel Sternberg, I believe is his last name. Yeah, his story about, I mean, I have his side, right? Which is basically, I forgot which org reached out to him and said, we'd like to, for you to add this in to curl. What was your side like? Did anybody else also reach out to you and say, "Hey, expect this guy to be coming looking for you," or are you interested to get this out, roll out to more people, or was there any kind of talk like that, or was it just one day that the comments that he made on GitHub that was your intro to what's going on?
Yeah, it was just one day. Daniel Stenberg showed up in the issue tracker, and so asking, "Is there a C API for Hyper?" And of course, I knew who Daniel was. I was kind of excited, like, I wonder if no, I shouldn't assume that. And so just naively or very casually, yeah, we don't have one yet, but if you have an interesting use case, we could probably figure it out. Oh yeah, interesting use case. Just a library that's used by billions of people. Um, and so we started working on an API that curl could use from C to make use of the code that's written in Rust and Hyper.
Yeah, that's pretty exciting, right? So you said you kind of held in your excitement and you kind of had an idea what it was, but your idea, you didn't really mention what your idea what it was, but it is what your idea was, is that you wanted to that he was looking at putting it in as a backend.
Yeah, I wasn't sure the company that reached out to him, I believe the Internet Security Research Group. I didn't know about their initiative at the time to try and fit in Hyper as a backend. I wasn't sure if he wanted to fully replace all the code or a backend that actually makes a ton of more sense. But that's what I eventually understood after going back a few times in the comments.
Yeah, but I did want to talk more about this part, right? So Rust does have this like kind of way to hook into C. I think both ways, right? So when you talk about, it's called a CABI, right? Can you talk more about what is a CABI and why it's something that's so? It's because it just doesn't feel like, I don't know. I don't know how to say this, but to me, like, I thought when you have a CABI, like it's more like straightforward where you could just kind of export some functions and then you're done. But it's more complicated process, right?
Yeah. So there's two things. There's an API, P like Peter, and then ABI like Bob. The B one is application binary interface. So it's the way that the programs agree to talk to each other, as opposed to the programming languages where we agree like what the functions are called. This is how the memory is laid out, so that way the programs can talk to the libraries can talk to each other, not the way humans do. But there is a neat. Rust has easy support for, like you said, you calling functions that are in C, but then also exporting functions so that they're callable from C. But you can't just slap on, hey, this is a C API as well, and everything's done, because the structure of way things work isn't exactly the same. You can call functions, but methods on an objects don't really have methods in C. So everything is a function. So now you need to, instead of using a foo : bar on something in Rust, you would need to make a function like foo _ bar and pass it a pointer to a foo thing. So there is a little bit of work there, and then there's also a bit more work around types aren't always easily transferable between the two. Like there might be a representation that Rust assumes that isn't the same that C could assume. So like for instance, a Boolean. A Boolean in Rust has a very specific layout in memory, whereas a Boolean in C kind of depends on the environment. It could be a small integer or a big integer, or it could be an enum, or it really depends. So you sometimes need to make sure to export a type that is compatible with C and then kind of translate it inside that C function.
Yeah, I know the type thing. I know I've done a little bit of FFI, and it's just quite interesting. And we have an upcoming guest to talk more about this in the future. But yeah, the FFI stuff is quite interesting. But the part that I don't like is that you just feel dirty and kind of like not safe, almost like I don't know, maybe attending a party and a little bit drunk already, and you're not really sure around you who what might happen, right? So I don't know, maybe that's a really weird analogy I'm giving, but because you have to kind of write unsafe everywhere, and you have to make sure that you handle the pointers and all that kind of stuff.
Yeah, I mean, unsafe doesn't have to be horrible. The idea of unsafe is it's a way for you to tell the compiler, and at the same time for the compiler to tell you, I need to be careful here because there's invariance that Rust, the compiler, is no longer enforcing. So when you're calling out to C, there's no way for the compiler to know what the C library is doing, and so it can't enforce those invariants. So it's a way of just saying, don't worry, I know what the C library is doing, and it's safe. Unsafe could be considered more like a trust me keyword, maybe.
Yeah, I forgot. We had another guest in here, and I forgot what he was talking about with unsafe. He has like another interesting way to look at the unsafe keyword. I forgot what it was. A lot of people say the trust me, but there was another definition he gave. I wish I could remember it. But yeah, just the problem of using the word unsafe. I think the reason that they chose this one is more to give you caution, because with Rust, everything just kind of works if it compiles. But once you have that unsafe keyword, you feel not safe, right? And the word unsafe automatically kind of makes you feel a little bit worried. So it's like, okay, I really need to be careful around this part. So you said it's what is it? So for the ABIs, is that actually inside of the Rust Hyper crate, or it's like another kind of glue crate?
So the C API is currently part of Hyper. There's a FFI module that has everything that is exported in C, and it's optional. It's a cargo feature flag, just like the client and server are. And so we run the tests in CI, and it works very similar to the rest of Hyper, and it's ideally not doing a whole lot extra. It's really just making sure that the types are compatible with what can be exposed to C and what is used internally. It's kind of the entirety of it, and making some functions that need to call a method, for instance.
When you test this stuff, how are you actually testing it? Are you actually writing a C program and then kind of doing some CLI through? Is this how you test it, or how are you testing that this thing works properly?
Yeah, there's two example kind of C programs that are in the repo. One's just a regular fetch, and another one is an upload to test out sending request payloads. And it's just tested just like all the other things. The client is tested by starting up a server and sending requests to it, and And the server is tested by connecting a TCP socket and pretending to be HTTP and seeing what happens, sending it bad HTTP, seeing that it responds correctly. So it's just more of the same as the rest of the library. And then there's also internal unit tests that test like things that don't need to go over the wire, that are just simple things. We can have internal unit tests in the modules themselves.
That's pretty cool. Is there anything that's curl specific, or I'm guessing all is kind of like available for whatever C library that wants to use Hyper?
Yeah, nothing is specific to curl, so it could be used by any C program that has a similar understanding or similar kind of flow. It just so happened that the API that we exposed for curl happened to match really well with the way curl does things in the first place. Because curl also works, my understanding, I could be wrong, by allowing the user of curl to plug it into any runtime environment they want. You can tell it, like, I'm using ePoll, I'm using select, or just regular poll, or whatever the runtime is, and you give it your own I/O, and then curl will run the HTTP over it. So it just so happens that Hyper does the exact same thing, just in Rust. And so it fit in really well there.
Okay, that's pretty cool. Have you actually ever tried using curl with your backend?
I have not taken the opportunity to learn how to build curl from source. One of the things that attracted me to Rust was how easy it was to get things running, and how easy it was to get dependencies pulled in and built, and I've just, I don't know, never taken the opportunity to try and build it from source myself. I've trusted that the CI that curl is running is working out just fine.
Yeah, that's what he also was saying. Is like, you don't really often build it. You just kind of use whatever your machine has, and that's good. And the fact that, we don't really know all the work that's going on behind it. We just feel curl's curl, and that's it, is also kind of the beauty of curl and the way the whole project's maintained. If actually, I'm not, now that I think about that, are you actually the same with Hyper? Is that there's stuff going on, but people just don't notice it?
I think that's the case with HTTP in general. You hear from a lot of people that HTTP is super simple, and I could rewrite this in a weekend. And then but that's kind of just a normal HTTP, not HTTP problem, a normal programming problem. But it's especially true of HTTP, where you think, there's so much code here, this should be so simple, and you rewrite it yourself, and then eventually you realize, there's this edge case I have to deal with, and there's this other edge case I have to deal with, and then eventually you have all of the code that was in the previous thing, when you could have just used the previous thing. So yeah, there's plenty of things that an HTTP library likely does for you that you don't think about at all.
When you mentioned these edge cases, I'm also thinking about Linus. I think you said when a bug becomes something that people rely upon, it's no longer a bug, now it's a feature.
Yes. There's I frequently bemoan that there's these specifications for HTTP that say exactly how it's supposed to work, but then there's reality where servers and user agents didn't follow the specification and expect the web to work the way they want it to work. And so then you end up having to work, well, this is what the spec says, but the real life says that I need to support it a little bit different, so I need to be less strict with this parser, but I can't be too lenient or else there's security problems. So yeah, you have this fun balance of dealing with the real world versus what specifications say.
So you mean Hyper is similar to any other software project, that whatever people say that they want and that it should do is still not exactly what they mean. So something like that.
Yeah, and that's true of HTTP, especially of HTTP 1. As the versions have gone forward, HTTP 2 did this a bit better, and HTTP 3 is doing this even better with things like grease and stuff. But especially HTTP 1, where it's just this textual format where people can eyeball it and say, like, yeah, that looks like HTTP. You have a lot of implementations that don't remember to include certain things. You have implementations that parse just what they think is right. And then with HTTP2 switching to a binary format, it got a bit more strict with, no, you can't choose between just carriage return a new line or new line, you always must use this format, for instance. But then there are a few places in the spec where, they'll say like, you should do this. And of course, anywhere where the spec said you should means that people interpreted it differently. And that's not very useful. So then in HP3, they did this neat thing where they said, you should be able to support other frame types. And we are going to basically chaos throw frames at you with random types to make sure that you don't goof on this. So that way you don't accidentally close off extending new frame types in the future, for instance. So they're getting better at it. But
what about adding in HTTP 3 support? Because that seems to be picking up a lot more steam recently.
Yeah, we're working on HP3 support. There's a few libraries that do HP3, and trying to figure out the right way to expose that at the abstraction layer that Hyper's at is a current goal of mine that I'm currently paying attention to this quarter.
So from 2 to 3, sorry, I was just curious. From 2 to 3 is a big difference, and you can go back to finishing your first thought.
Yeah, I was going to say that we've had a couple of contributors paying attention to HP3 quite a bit for the past year and doing fantastic work. Yeah, you said there's quite a bit of difference between 2 and 3. That was what you asked?
I was curious if there is. They seem, on top of the hood, they seem kind of similar where you have to have HTTPS. I think HTTP3 is probably building upon HTTP2. I'm not too sure. It seems like from 1 to 2, it took a long time, but from 2 to 3, it's like, didn't we just have HTTP2? Why the heck do we need HTTP3? What's the benefit?
Yeah. In some ways, they're pretty similar, being able to multiplex multiple streams over the same connection. So you don't have to open a whole bunch of sockets to make a bunch of requests to the same destination. In that sense, they're similar. They have frame types, binary frame types, instead of using text where you say, in HTTP1, you split up the headers and the body by just having an additional extra empty line. Whereas in these other HTTP2 and 3, you actually have frames with identifiers to identify this is the kind of frame. So this is a headers frame, this is a data frame, and so forth. The HTTP3 has that as well, but the major thing that it did was it moved to Quick as the underlying transport layer. And it took a lot of things that HTTP2 had and shoved them down into Quick. And so HTTP3 in some ways is simpler because it doesn't have HTTP3 doesn't have to really multiplex. That's being done by Quick. It doesn't need to do flow control. That's being done by Quick. But the harder thing is that it's a completely different transport. Most HTTP 1 and 2 is usually done over TCP. You could do it over Unix streams or something like that. But the big thing is Quick being over UDP and a bunch of stuff on top of it being encrypted by default. It has a different I/O model. You could model it the same, but it's not immediately the same as a TCP socket is. That's probably the biggest difference.
Okay. I do want to go back to one more thing. So we always think about kind of using C within our Rust programs, but not too many people talk about using Rust in their C programs. Like you said, you have to make the API. Now, if you're in this part where you're having C calling into Rust, on the Rust side, is there anything that you need to kind of really consider? So, for instance, Daniel brought up the thing about, okay, when you're working with C, you're expecting that an error, like maybe a null pointer that you passed in, would get errored out much quicker than if you're using with Rust because of the async runtime. If that makes sense to you. That was just kind of not necessarily complaint, but it's something that he has to kind of get used to when using Rust and saying, okay, if I pass a pointer in there and it's null, and I start kind of working on something else and all of a sudden I get an error, I got to deal with this. And this is something that is definitely different than working with other C libraries. But now if you're writing a Rust library to be used in C, is there something that you really need to kind of keep in mind or something that is a little bit annoying?
Sure. Let me address both of those. So I think in that case around like null pointers, that's probably a difference in Rust. we don't have null pointers, caveat. You always have something behind that pointer, unless it's a raw pointer. But most Rust, you just always use a reference. And so you never check that something is null. Whereas I imagine, I'm going to guess here because I don't write tons of C. I imagine when you're accepting a pointer, you might check, hey, is this a null pointer? If so, just immediately return that you goofed up. So that might have been a difference there in that in the C API, we didn't bother to check, is this a null pointer? Just kind of assuming like, oh, the user's not going to pass us a null pointer. They're going to be good. Whereas I imagine Daniel was kind of hoping, no, we're humans. We're not always going to be good. So please catch it faster. The other side to your question is there something from Rust that we have to think about? Yes. Well, I mean, we kind of talked about it a bit. That like assuming that things can be null or not. There's some things around types that I've mentioned before, like you have enums in Rust, enums, enums, however you want to pronounce it. And you can use represc on them so that way they equal an integer. But if you were to ever allow someone to pass you an enum as an argument, and they were to choose an integer that was out of range, in Rust, that's undefined behavior, and you can find dragons there. So that's another thing you have to worry about is instead of exporting the actual enum type, maybe export an integer, and then you do the mapping yourself into the enum and return an error quickly if it's out of scope.
You can actually export enums in a safe way? Okay.
No, you cannot.
No? Okay.
You can export them, but if you can export them, that's fine. If you accept them as an argument, then you probably you can be in for a bad time because there's nothing stopping the C library from calling it with a say your enum has 6 variants. There's nothing if they pass in the number 10, all bets are off.
Oh, when you export it, then it's just coming as numbers then.
Yeah, and C enums are just numbers.
Okay, that makes sense.
They're also just numbers in Rust too, but the compiler is able to know every place that it's used and ensure that you don't ever use anything that's out of the range of the enum. Whereas in C, it's the Wild West.
Yeah. Is there anything else you wanted to discuss about, like any upcoming plans for Hyper people should be aware of, or things that people should really know about Hyper, or maybe there's a call out that you want people to come contribute to something, or just to Hyper in general?
So right now we're trying to figure out a kind of 1.0 release to Hyper. So Hyper's been pre 1.0 since it's existed, and that's in some ways that's meant that it's not stable. But I mean it's used in production by tons of things, and what does that really even mean? It's more kind of at this point 1.0 and Rust crates is kind of a marketing thing. So the goal here is to come up with, okay, we promise not to change it in at least a long time, where we don't define what a long time is, but a bit more than just a year. But there's some things around that we want to really refine the API, probably chop some things that are not good enough, so that way we can keep things stable and say like, well, the not good enough things, go use a hyperutil crate or something like that. So we're trying to figure out the 1.0, hopefully this quarter. And there's some discussion around that in the Discord, and I'll be filing more issues around things to add or chop or what to focus on. So that, and of course, there's always plenty of things to work on. So if anyone is interested in HTTP work in Rust, we have some easy issues, we have medium issues. We always love to have maintainers, and we take good care of them. We don't bite.
Yeah, I think the Rust community is really welcoming and good. And it's good. I was going to ask if you have easy issues that people can kind of come in as a first timer. I always thought that it's kind of weird. Like, to me, if it's something easy, why not just do it now and just get it over with? Is it just like you're just trying to get the community open and it's not super pressing?
Yes. So easy issues, usually it is always easier for me to do the easy issue myself. It takes more work to bother to write it out and write out mentoring steps and help someone go through the pull request process. Probably it's the first time or second time. That takes more work. But because it was easier, people might feel more willing to try it. It's not as scary. And maybe they feel good about themselves. They learn something. Maybe they stick around and keep contributing. Uh, it's really for the benefit of other people to show up. I'm not really getting anything from that small issue being taken care of. Now, if they turn into a regular contributor, then the project has gotten something from that too, of course.
Okay, that's pretty good. Of course, you need to always with any new thing, having a quick win, it definitely keeps you going rather than having something that takes you a long time and you lose interest and kind of get let down.
Yeah, exactly.
Okay, I think if there's nothing else, then we can start to wrap up. I think there's basically just kind of like one question on here that I think is really good to kind of answer, right? As somebody who's pretty well versed in Rust, right? Going from JavaScript to Rust is a huge change, right? And also sticking with Rust for such a long time. So do you have some advice for people who are interested to get started with Rust and maybe are struggling or not quite sure where to start?
Yeah, sure. So if you're brand new to Rust, there's the Rust book. It's on the main website. It's really great. Walks you through all the concepts of Rust. If you like a kind of different style of learning, there's Rust by Example as another website where you just kind of work through some examples and learn Rust in kind of a more like build something kind of learning style. Those are really good to if like you're brand new and you have no idea what anything does in Rust. But once you know just a little bit, and I know I'm biased here, but that's fine. I think you really would benefit from just picking whatever area of you care about. If it's networking, then something in HTTP or something like that. But maybe it's game development, or maybe it's WASM or whatever. You pick an area that you care about. You find a decent sized open source project that has issues for you to tackle, and you just jump in. I see people mention, but what if I write a bad one? I don't want to annoy the maintainers. No, don't worry about that at all. The community is great. Nobody's going to be upset that you tried to fix something. You're going to learn how a larger project does something, not just an example, or how to write FizzBuzz or something. You're going to feel good about making the internet a little bit better, and you're also building a reputation. You're building a body of work that you can point to after a while. Like, hey, I've been working on this open source project for a while, and maybe it helps you find a job. Maybe you become a regular contributor. It's the best thing I think anyone can do is try and get into open source in Rust, especially Hyper.
I was going to ask, did you ever imagine that you'd be on this podcast someday talking about some kind of pet project? I guess you kind of thought it was a pet project a long time ago.
I did not ever think about getting on podcasts. But it's really cool, and thanks for having me. This is really fun.
No, I mean, this is a way to kind of for people to kind of get to know more about you, the project, and definitely highlight that if people don't know what is Hyper, what is Hyper? Tell them all about it and let them know what's going on and everything. Because I think Rust community is so big. Like you said, if you could be interested in game development, you could be interested in writing services, whatever you want to do. But yeah, the Rust community is so big that you can really silo yourself. So it's good to kind of reach out to other communities and say, okay, what's this thing? And you may want to use it, right? I mean, so many games, they're online. So they may want to use Hyper for that kind of stuff. So again, really thank you for making the time twice now. So just so people know, I totally forgot about our last our last meetup. So I'm glad that you weren't too sour and definitely scheduled again. And I appreciate it.
Oh, it's my pleasure.
Great. If nothing else, then I thank you for what's going on. Maybe we can have you back when there's maybe some H3 support. We can talk more about adding H3 to Hyper and how was the journey and etc.
Yeah, that would be fun. Let's do it.
Sounds good. All right. Till then.